Hello friends, I am Akshata Puranik and I am going to explain power diode and static characteristics of power diode. So power diode is a typical diode that is commonly used in power circuit, electronic circuits. The diode is simple semiconductor device that includes three layers and two terminals, that is P, N plus and N minus, and two terminals anode and cathode. So there is a single in a, in regular diode there is single junction and conducts current in only one direction, but in power diode, to increase the power handling capacity, we use power diode by small changing in the structure of a simple PN junction diode. So power diode having three layers like P plus layer, N minus layer and N plus layer. The upper layer is a P plus layer and it is heavily doped. In the lower layer is a N plus layer and it also heavily doped, and middle layer is N minus layer, so it is in lightly doped. So the heavily doped upper and lower P plus and N plus is called as terminal layers. So the terminal layers is always heavily doped to increase the conductivity of the device. So this is the circuit diagram of power diode. So P side is anode and N minus side is cathode. This is the junction diagram. So P plus, N minus and N plus, that is, it forms anode and cathode. So N minus layer is the only difference between power diode and regular diode. So this is due to N minus layer is added due to lightly doping concentration, as we know that thickness of space charge region increase with the decrease in concentration. So increased thickness of depletion layer of space charge region helps to diode to block a larger reverse bias voltage and hence have greater breakdown voltage. So the N minus layer is key to the feature of power diode, which makes it suitable for high power application. This layer is very lightly doped, almost intrinsic, and hence the device is known as PIN diode, where I stands for intrinsic. So as we know, we can see in figure. So net charge neutralization space charge region is still maintained as was in case in signal diode, but the thickness of space charge region is quite high and deeply penetrate into N minus layer. So the doping level between P and N is same as in PN junction, but in power diode we have junction formed between P plus and lightly doped N minus layer here. So hence structure looks like this junctional figure. So this is about the construction of PN junction diode. So let see the VI characteristics of power diode. So the power diode has following VI characteristics almost similar to that of the signal diode, that is regular diode. So the VI characteristic of power diode is similar to the PN junction diode. So the where we increased when we increase a forward voltage, that is V plus, forward current increases linearly. So in forward bias condition, when anode is positive with respect to cathode, forward current increases linearly with increase in forward voltage. In reverse bias condition, when cathode is with respect to anode, does not conduct, diode experiences increases linearly with the increase in forward voltage. So in reverse bias condition, experiences a small current flow in the reverse direction called as reverse leakage current. That is, this is the leakage current that flows in reverse condition. So this saturation current flows due to the moment of minority carrier. This reverse saturation current is independent of applied reverse bias voltage. So it is irrespective of applied reverse voltage. So it is present naturally leakage current. If reverse applied voltage continuously increases, after certain reverse applied voltage, a large reverse current flows through the device and depletion layer will be destroyed. That the reverse voltage is called as reverse breakdown voltage, that is VBR, and results into large reverse current flow. So this large current will destroy the diode easily. So there are, this is the VI characteristics of power diode, similar to diode or SCR. So at forward junction potential, diode starts conduction. So forward conduction mode is called as conduction mode. Here diode starts to operate. It is approximately 0.7 or 7.5 for germanium and 0.7 for silicon. So let's see the reverse recovery characteristics of power diode. So the reverse recovery characteristics of power diode is shown in following figure. The AC diode is characterized by forward recovery time TF and reverse recovery time TRR. So forward recovery time, so this is recovery time is required by a diode to start the conduction, is called as forward recovery time. In other words, time taken by the diode to switch from off state to on state is called as forward recovery time. So second one is reverse recovery time. So after the forward diode current decays to zero, the conduction continue to conduct the reverse direction because of the presence of stored charges in two layers. The reverse flow for the time called is reverse recovery time.